Ladies and gentlemen, we're going to continue our discussion of mechanisms. Here is how they might look on a test. This was an old test question from spring 18, test 2, part 4. And it's worth a lot of points. The reason this is here, stop labeling LA, BA, E, and new. That's going to be question 1 on your test, where you do the labeling. And I want you to know for sure that you're not supposed to label anymore. So stop. Okay. All right. This is just the mechanism and the major and explaining your choice. Now, off camera, we kind of decided this was our favorite because we just did a video where we said if we can get rid of ring size 4, that is the best thing you can do in terms of stability, the best thing possible. So we'll be explaining why we like that one, but you should always do your explanation based on your carbocations. They're the ones that are in the rate determining step. So they're the ones you need to help the most. First step of any mechanism done next Monday is to attack a strong acid with pi electrons, regardless. Okay, so you're doing that. So find your pi electrons, attack your strong acid. Sulfuric acid, do not attack water. Do not attack weaker acids before stronger acids. You're going to generate 2 carbocations. Please always generate 2 carbocations. You've got 2 carbons in an alkene. Each one of those is a candidate to be a carbocation. Draw them both. You got a 4 fused to a 6. The one cation has it right off the bridgehead by 1 carbon, and the other has it off the same bridgehead, but it's on the 2nd carbon. And then ask yourself this simple question. Do you see any of the products resulting from direct attack on the cation with water? And I only see 1 product possible from that. Which cation gets attacked to create the conjugate acid of one of the products? The first one. And you can use the water that's already on the page. One-time offer. Put a lone pair on it and make sure it comes all the way to that carbon. And draw me the result, which has to be an oxonium ion. You got your new O over here. There's 2 H's on it still. I want to remind you, you made sulfate ion that has an H on it, also called hydrogen sulfate. When you made your cation, you're going to need both sulfates eventually. So might as well have them drawn. So I can see that first product happening. The conjugate base of sulfate comes back and grabs the H from your oxonium. O gets a lone pair, and it became product number 1. I see this becoming a cation here by shifting something and then making this product. What's the thing on this carbon that is, which atom is on this carbon here that is not on the same carbon here? Because that's what moves. There's a hydrogen on this carbon here that is not on this carbon here. You know it moves. Draw the hydrogen. Start the arrow on the middle of the sigma bond and go all the way to the C. And draw the cation that results. It'll be tertiary, so it'll be an improvement. Tertiary, that's why it happened. But it's not the best carbocation. We'll be seeing that later. Okay. So how does that become an oxonium? The conjugate acid oxonium of our guy here. Needs to become that, but you got to show me that new bond happening. Where's it come from? You draw another H2O. And you make sure that lone pair makes a bond with an arrow all the way to the C. And then how does the oxonium become the third product there? How did the other oxonium become the first product? Sulfate ion grabs H. We have a sulfate already here. Grabs H. Right there. We got to spend a little time on product number 2 now. We got to ask ourselves which carbocation can rearrange to this cation. And guys, if you're stuck on rearrangements, which can happen, do we agree that that second product can only come from this carbocation regardless? Look at the cation. How do you know that's the only cation that can give this alcohol? It's got the positive where the O ends up. Just like, how do you know this cation is the one that gives this alcohol? It's got the cation where the O ends up. Just like this cation becomes this alcohol. It's got the cation where the O ends up. So even if you didn't know how to rearrange it, you get a point for drawing the cation that was right before this. I mean, you just copied the carbons, didn't you? Yeah. And then I asked this question, which of these two cations can rearrange to that? And I got a tip for you. You ready for the tip? Carbocations will rearrange from a branched carbon adjacent to a carbocation. Carbocation rearrangement will only occur from a branched carbon that's on an adjacent position to a cation. So on this right here, this is a branched carbon. I didn't copy it right. I did copy it. Sorry, this cation. We're asking which of these two cations. I forgot my question. That's my problem. Which of these two cations can rearrange to this one? Well, does this have a branched position adjacent to the cation? Yes, right there. Does this have a branched position? Yeah, it does. And we already did that rearrangement. But we don't have an adjacent on this position, which means we can't rearrange that ring. But that ring, cyclobutane, is one away from the cation. That's the giveaway. So what you do is, you tell me why you can't do this. Do not write a thing. Do not dare write down what I'm about to write down. Tell me what's wrong with going back to this one and doing this. I drew this orange arrow here, which I will erase as soon as I can. You just told me this carbon is both being attacked by water and being rearranged to get a fifth bond, by the way. At the same time, none of these happen in our reality. One thing happens at a time in chemistry in reality. So, guys, you need to tell me that Yeah, this one you did this chemistry with was one version of this cation. I need another version of it that's going to do something else. It's like I got 4,000 cations in a room. 3,000 of them are going to do this thing. You do that mechanism. And 1,000 of them are going to do it this way, a different way. Right? It's not like you're violating the raw law of constant mass or anything. You're splitting up your cation and saying, I'm going to do this sometimes and this other thing other times. How do you show that? You get rid of this guy's picture and you say, I need a second copy of this cation. That's what I'm going to copy. I'm just going to copy it. No tricks. How do I know I needed that one? Well, it's the one that had the branch one away from cyclobutane. I'm sorry, it had the cation one away from cyclobutane. Cyclobutane is the branch. And your choices of rearranging are three, but only one of them is good. You could rearrange this H, and you'd still have cyclobutane. You could rearrange this bond and get a bigger ring. Or you can rearrange this bond and get a ring. All three of them are possible. Two of them got rid of the small ring and made big. That's good. Moving the H doesn't help you at all. Do you see a product where you have this, the OH on this position and the ring stayed the same? You do not have that product. So I'm going to do this one carefully with labels so you can see it because it's the first time you've learned. Same labels as before. I like the A, B, C, D, E thing. And copy things down without moving things. I copied everything except the bond I broke. Do you agree? Everything except that bond I broke has been copied. Where are the arrows now? Give me letters as I copy the letters down. The new bond is between what letters? New bond is between A and E were already bonded, and I still have that bond. D and E. Sorry, I misheard you. My apologies. And then you put the cation on A, and you say, wait, Dr. Whitaker, it's secondary. You don't do this rearrangement. And I say you forgot. There's one thing that's even more important than primary, secondary, or tertiary for cation, and that is ring size. Cyclobutane or cyclopropane, that is much more important than hyperconjugation. And when I say hyperconjugation, that's when you're saying the degree sign. Tertiary has more hyperconjugation than secondary, has more hyperconjugation than primary. Read about this hyperconjugation, please.
Doesn't torsion mean close together?
Torsion means this action, twisting. Okay? Torsional strain means your ring is preventing you from twisting away from strain. The ring was too small. And I think that's going to give us our product. Ladies and gentlemen, I know you might not see it, but are they not identical? Cation, one away from a bridgehead. Bridge size is 5 on the left, 5 on the right. Ring size, sorry. And the isopropyl off the second carbon from the top. They are the same thing. And how do you get the O to be on the oxonium? We see one version still on the screen. H2O, number 3. And you're saying, where's all this water coming from? I answer this, water is everywhere in this problem. It's the solvent. There's more water than you can shake a stick at. I don't want red crossing red. But I want that arrow to clearly stop at the carbon, not the plus. And I draw my almost final product. This is going to go to the middle one, which is major. We'll be explaining it shortly. What's going to take the H off, though? hydrogen sulfate, but we don't have any on the screen. So what do? Redraw it. Yeah, don't have another one that you've already used again. Goes to major. And for my explanation, I'm going to do it over here with the cation. Carbocation, I need those magic words about strain. Carbocation has lower, what are the two types of strain? Torsional strain. And what's the other one? The 90-degree thing was bad. 60 would be worse. What are those degrees? Angle. Oh, wow. All right, that's the whole deal. I think B was explained, right? Circle major and explain my choice. There you go. And if you look back at question 1 on the same test, you had to explain the major then, and that wasn't about rings, that one. That was about hyperconjugation. So on your test, on your first 2 questions of short answer, one of them will have ring size getting better. You'll need to talk about angle and torsional strain in one of them, and the other one will be straight up about hyperconjugation. Okay? Primary versus secondary versus tertiary. Yeah, and if that's not dropping hints, I don't know what is.